Hello guys, it's Dr. AJ. Today we have 3 examples on permeability. It's a very important topic in the FE exam, so let's get started. So the first example says find the hydraulic conductivity in centimeter per second. First, hydraulic conductivity can be called coefficient of permeability, and it usually uses the letter K to indicate the hydraulic conductivity. Number 2, it's in centimeter per second. It's as if you're trying to describe a speed, length over time. Please pay attention to the unit based on constant head permeability test setup. So this is very important word because we have 2 types of tests we can use to determine the hydraulic conductivity, or sometimes called, as I said, the coefficient of permeability. The first one is called constant head. The second one is falling head. Why I'm trying to emphasize on the top of the test? Because there is a different equation for each one. When I use the constant head, it has its own equation. When I use the falling head, it has its own equation too. So that's why it's important to know what type of permeability test was done. So, and also the parameters are given. L 50 centimeter, L basically the length of soil specimen. This is the red one, is the soil specimen. A 250 centimeter squared is the area. What area? The cross-sectional area of the specimen, the soil specimen. H, or sometimes called delta H, it is the difference in the piezometric pressure reading. So please pay attention to this one because it's sometimes they can trick you. What they're gonna bring to you is the length from one of them to the collecting container. So I don't want you to get confused. It is the difference in the pressure when you do 2 readings in the piezometer. So if it was given from here to here, this is not delta H. Delta H is basically the difference in the piezometer, okay? And the water collected volume in 10 minutes, so pay attention, 10 minutes, we have to convert that into seconds, is 700 centimeter cubic. So, and then we have 4 options. So, as usual, we start writing down what is given, right? So L 50 from here to here, it's given. A 250, as we said, the cross-sectional area. H is this one, the difference in the head, 70 centimeter. T is the time. Q is basically the volume. We write down the equation. You go to your FE reference manual. Please, this is the constant head test. Please pay attention to that one. This is the equation. K is the hydraulic conductivity, or sometimes called the coefficient of permeability. That's what we're looking for. Q is the volume. What volume? The volume of water collected in that container. I is the hydraulic gradient, and we will describe that. A is the area of the soil specimen, and T is basically the time of the test. I mean the duration. So I, it's, as we said, the hydraulic gradient is the change in the pressure head over the length of the specimen. So we have 70, it's given, centimeter, the H, L of the specimen 50, so the I, the hydraulic gradient, is going to be 1.4. Now everything is basically given. Q, we have it, 700. I, we just found that, 1.4. A, it's given 250, and T sub E, it's 10 minutes. We just need to convert it. So times 60 so that we can make it in seconds. And that's going to give us 3.33 times 10 to the power minus 3 centimeter per second. We go to the option, it's option A. So example 2. Also, they are looking for the hydraulic conductivity, as we said, or can be called coefficient of permeability. Centimeter per second, please pay attention to the unit, but this time they're using the falling head test, so it's a different equation. You go to your FE reference manual, to the geotechnic topics, you go to the permeability, you'll see there are 2 equations, one for the constant head, the second one for the falling head. This one, you're going to choose the falling head test. So And they are giving us a bunch of parameters. The specimen's length, it's L, the soil. Area of the soil specimen is this one, is the cross-sectional area. It's given as well. Area of standpipe, it's this one. And head difference at times equal to second is 600. It's from here, the collecting. This is the container that collects the water to the standing pipe. This is the first pressure. And then as the test is going on, the head of the water is going to go lower and lower, so until it stays at certain points after certain seconds or certain minutes. So at 200, after 200 seconds, we get a 400 millimeter depth. So if you measure from here to here, you're going to get 400 millimeter, and that was the drop after 200 seconds. And also, as we said, we're looking for the coefficient of permeability or hydraulic conductivity. So the solution, as we start always, we write down what is given. If you don't have time, it's okay. I'm just trying here to make it easy for you. So I usually start by writing down what is given. So falling head test, this is very important. We're looking for the K in centimeter per second. I usually put that too because units are very important. So we go to your FE reference manual and you're going to see this equation, 2.3 and then A times L over A times TE, and then we use the log. H1, H2 is the difference in the head at certain time, 0 and time, specific time, 200 seconds and hours. So this is basically the A is given, A capital is given, the soil specimen. L is given, it's here. A is this one. The small a is this one. H naught or H1 at 0 second is 600 millimeters. Sometimes, by the way, it's called H naught. This is very important too. H2 is after the drop at certain time, 200 seconds. So we got H2 400. We're just gonna plug in some numbers and we're good. So 2.3, 35, this is the small a, 275, the big L, which is the specimen's length, not the container, the specimen, the soil specimen. So guys, please pay attention. A is the specimen's cross-sectional area, 800 is given, time it's 200. So we're not going to use the first because it starts at time 0 and then it stops at a certain time we choose or it's given for us. In this case, it's 200 seconds. So we put that. Please pay attention to the second or minute because it's going to make a lot of difference in your answer. And then we use the log 600 over 400. H1, it has to be bigger than H2 because it's a dropping. We're reducing the elevation in the head. So 600 over 400, and that's basically is going to give us 0.024 millimeter per second. And we need to pay attention. We're looking for centimeters, so we convert that. It's going to be 2.44 times 10 to the power minus 3. We just divide that by 10 to convert it from millimeter to centimeter. So that's going to give us basically option B. Also, one more thing, please pay attention to the units. See, like, look at option A, it's the exact right number, but the units are wrong in millimeter per second. Here we're looking for centimeter per second, so that's why it's option B. Example 3. This one, it's very important. It's tricky for the FE exam, but I just felt it's important to put it because you might get something like that in the test. So let's get started with this one. So it's a constant hand test was done to find the permeability. The flow charge is what they're looking for in centimeter cubic per second. The sample length is given is 70 centimeter. This is L. Area of soil specimen A is 210 centimeters squared. It's given 2. Now all the units are the same. Constant hand difference, this is the delta H, or sometimes called H, is 28 centimeters. It's given to hydraulic conductivity or coefficient of permeability is given. What we're looking for, the flow charge. So as usual, start solution, writing down what is given. Constant hand test was performed because, as we said, the equation is different from the following test. Q, I just put that symbol for the discharge, centimeter cubic per second. That's what we're looking for. L is given, the length A, H, and K is given. So this is basically from your reference manual. K is the hydraulic conductivity equal the volume of the water collected divided by I is the hydraulic gradient. As we said, it's delta H over L, or sometimes called H over L. A is basically the cross-sectional area of the soil, and T sub E is the elapsed time. So, but what we're looking for here is the discharge. So volume over time, it's gonna give us a discharge. So if you, this is basically the constant coefficient of permeability equation, right? This is what you have in your reference manual. This term, Q over time, it's gonna give us the discharge. So we can substitute the Q over TE by just Q, right? Q over TE, let's just put it Q. So K in this case is gonna be Q over IA, right? Because the Q is basically the Q capital, the volume over the elapsed time, which is T. So now this is basically, we don't know what we're trying to find. K is given, I, we can find that easily because it's just H, the 28 divided by L, and A is the cross-sectional area of the specimen, and it's given. So this is going to be the equation. 2.1 times 10 to the power minus 3, this is the K. 28, it's basically the H over L, 70, and 210 is the area, and that's going to give us almost 0.18 cubic centimeter per second. So it's option D. With that, thank you very much, and see you next time.